Most RAG agents are basically useless and mostly suck. That's probably because you're stuffing them with irrelevant context. I've spent thousands of hours building AI systems with RAG properties for businesses, multiple small businesses. And Cohere's Reranker, which is how we're going to fix this problem, is changing the game of how I think about RAG workflows. In fact, it's 30.8% better than other RAG methods. But in this video, you have a RAG agent that actually uses relevant information to answer your questions instead of generic baked-in knowledge in the LLM's knowledge base. So I'm going to show you exactly how you can build this agent using n8n and Cohere Reranker, and I'll be giving away this template at the end as well. And if you haven't seen my face before and you're new to the channel, I'm Namisi, and I help small businesses implement AI and see the real use cases of where AI can be implemented. I spent over 1,500 hours building systems for clients of mine and personal projects as well. And I share literally everything I learn right here on this YouTube channel. So if you want to see how Cohere Reranker can change the way your business interacts with its documents and all of its context, hit the link in the description down below and book a free 30-minute AI audit. So now let's just get straight into the video. So now I'm just going to quickly explain what RAG is and why it's important for a bit of context and why this Cohere Reranker is really changing the way we should be looking at RAG. I'm briefly going to touch theory, but I'm not going to go too much in depth right here. It's just a really high level overview of what's happening behind the scenes. So standard vector search is like asking someone to find a needle in a haystack while blindfolded. So to put a bit more context here, you're compressing the meaning of entire documents into single vector points. So now if we were to use an analogy here, say I ask you what is the weather in San Francisco. You don't know that off the top of your head, so you'll probably go to Google and you'll search up what is the weather in San Francisco right now, and you'll probably see like a Google excerpt here with the temperature, and you can give me that answer based with that information, right? And you as a human, you know that probably the most accurate answer is right there at the top, but LLM here probably doesn't know that. So what happens, and the way LLMs work, is you're going to feed a whole bunch of context to them. So if I ask an LLM the same question and pretend it has access to Google search, instead of just looking at the first option there and giving that to me, it'll look at the first 10 pages, right? And you'll lose critical context in that search. So you might get temperatures from San Francisco from 2 weeks ago, but ask about now. You might get a different San Francisco. I don't know if there's a different San Francisco in the world, but you kind of get the idea. It'll lose context, and search accuracy diminishes as the document complexity increases. And that kind of makes sense. If there's more pages in the Google search page, it'll get more confused with what information it should actually give back to me. So that's the vector search limitations. And now let's talk about why context gets lost in LLMs. And it really boils down to the theory of lost in the middle, right, problem. That's why when you're prompting, it's probably best practice that you've seen to have your role prompt at the beginning and like some notes which you have at the bottom, which you might add to the prompt after you've had some generations and see some output which you're not really liking. So the old way of vector search is through bi-encoding, right? Your query and documents are embedded separately, sometimes very far apart. So the normal way of doing RAG is you ingest your documents into the vector database later, and then you query that vector database, and your query and documents are put in different places and they're embedded separately. But cross-encoding is what Cohere does, processes your query and documents together for similarity scoring. And based off the similarity scoring, Cohere's Reranker selects the top 3. That's the limitation of n8n. There's workarounds to get more relevant chunks, and gives that to the LLM to give it more context to answer your questions. And usually, the bi-encoder does top K, so you'll probably bring back your top 20, and you're going to stuff that into your LLM prompt, and it's going to lose that critical context in the middle. That's why it's not that good. If we go back, it's going to lose that critical context in the middle. So re-ranking provides contextual understanding that vector search alone cannot achieve. So let's talk about the business impact and actually why this is important. From hallucinations to real answers. So you might be having RAG agents right now that you ask questions and it starts hallucinating, basically using its baked-in knowledge and its training data, not your RAG enabled workflows. So standard RAG chatbots miss critical information in complex queries. Re-ranking prioritizes the most relevant context for each query and potential support tickets to drop answers based on your company documents. So before, standard vector search, how do I connect my API to workflow? So you've got some documents in your database, and that shows how to connect APIs. Before, it'll say, I'm sorry, I don't know how to help with that specific question, because it'll probably bring back so many things and it could just confuse the LLM. And after, with the ranking, it'll give you the exact answer. So why now, right? Native Cohere Reranker is new in n8n, but it's been around for, I think, about a couple of months now. But you'd have to do some complex workaround, like using HTTP calls and everything like that, like a post with the authorization, JSON string and everything like that. Now it's just a simple toggle in n8n, right? And this is perfect for businesses to implement simple workflows without the complexity of HTTP calls and all of that. So I think that's enough for theory, and I think we know enough now to get straight into the n8n workflow. So the chatbot we're going to be creating is, say, for FIFA right here, that people can ask any questions and understand the rules of the game. Say like a VAR call or something dodgy happens on a football game. So we're going to do two things here. The first thing that we're going to do is create a workflow that ingests the document into the vector store. And the next workflow which we're going to do is basically create the AI agent with the Cohere Reranker that will use this information here to answer any questions which you might have about the rules and regulations of the game. So if you don't have an n8n account, you can just head over to n8n.com, or is it n8n.io actually, and you can just sign in here and get started. There's I think a 20-day free trial, so if you don't have an account, you can get started. Or you can be self-hosted. Self-hosting is a whole different thing. I'm self-hosted because it's just a lot cheaper than the cloud, and you just got a whole lot of customizability and like custom nodes that you can use. So I'm just going to get into my n8n workflow, and we're going to start off with the first part here. So once you're in n8n, what you're going to want to do is just create a new workflow in the top right over there. Wait for it to load. And this is going to be our first workflow, which is going to be ingest FIFA documents into DB. That's a database basically. And I'm just going to have it a manual trigger for now. You can basically set it up so whenever you upload it to a Google Drive file, it'll go ahead and do all of these things. The next thing that we're going to do is add a Google Drive node. And here is Google Drive, and what we're going to do is we are just going to search files and folders, right? And that'll basically search the file which we upload the document into, and it's going to basically, if you upload many documents, it can loop through all of them and understand that. So we're going to search files and folders next. So to actually use Google Drive in your n8n, you're going to have to make a connection there, and I'll have a link in this to a video in the description down below that'll walk you through how to make this connection. Basically, it's going to include your Google console and just activating the APIs, Google Drive API on that Google console and connecting n8n. But once you just got your client ID and client secret, you can just paste them here, and you're good to go. So next up, so we're actually going to search files and folders. So I'm going to go to my Google Drive. We're going to create a new file, a folder, which we're going to put the FIFA documents into. So here I've got FIFA rules as a new document or a new folder in my Google Drive. I'm just going to go over to the FIFA rules. I'm just going to download this FIFA files and just put it straight into the Google Drive. Yep, so here are the FIFA rules straight in my Google Drive, and we'll use this information to answer any questions which the user has based on these documents. So now what we're going to do is we're going to go file, folder, operation, search message, search file / folder name, and what we're going to add here is we're going to add a folder, and then what we want to do is, this is basically the filter, and we basically just want FIFA rules right there, and now it's going to basically list all the files that are in there. So if we just test it to see if it's working, you can see that we've got this ID and FIFA disciplinary code right there. So that's literally everything there. So actually, since we got one file in there, we're just going to basically handle any edge cases which you might have. So if you have more than one file, we just have to loop over them and upload them to the database separately. So to do that, we're going to go to loop over items, and we're just going to have it like that. And we're just going to delete that. So the next the next node that we need to add is a Google Drive node. It's to download the actual file, because that we just got the list of it. Now we need to download the binary data. And what we're going to do is we're going to go by ID, and it's going to execute previous node. We can't actually execute previous node because we need to get the information here. But essentially, we're going to use an expression, and we're going to put in JSON dot item dot we just need to make sure we're getting the correct information here, dot ID. So that will basically give us so this JSON string is basically just referencing the previous node, and this node item is going to be looping over just the number of files which are in the Google Drive, and it's just going to be getting the ID and the name. So we're going to use that to download the file. So if we just click this, we can kind of see if it works. Okay, that did not work. Instead, what we can do is just grab this here and put that there. Cool. Now it should work. If we click on the workflow, executing workflow, It's downloaded. Okay, cool. So now this is in binary data, and we want to actually extract the text which is in this file, not just all this metadata here. We can kind of use our own metadata later down the line, but we just don't want to confuse the actual LLM calls or the RAG searches when we're going through that part of the workflow. So to do that, we're just going to extract from file. We just want to extract from PDF right there, and we just want to add options, and we're just going to click that. We don't actually need to add any options. Just going to pin it. Input binary field is data. Just going to match the name right there. It's going to extract from PDF. There's no other options which we need there. So we're just going to run this workflow to kind of see what we get, to make sure everything goes through correctly. Just going to have it download the file again. I don't know what happened there. It didn't actually download the file. It just used the previous node's information. There we go. So now we've got all the info in its own category. We've got metadata as well, and we just got the text. We just want this text basically, and that's all we want. So now we just need to use an edit fields node, because the way the Supabase integration, which I'll walk you through in setting up, works is that it'll use JSON data, and the only JSON data which you want to be inputting is the text. So we're going to put that right there, and we're just going to give it the name text. Cool. So once we've got that, we can just pin these so everything is working, and we can just also just test this to see if it's working. I have that extract data from file, and there we go. You can see we just got text. And now the next thing that we're going to be using is Supabase, and we want to, not Supabase, we want Supabase Vector Store, and we want to add documents to Vector Store. That's what we want. And I'm going to walk you through setting up your Supabase and literally everything that you need to do there. So this is Supabase. If you don't have an account, you can just sign up, and if you do, you can just sign in with Google GitHub or then SSO. I'm just going to sign in with GitHub, right? And you might have projects, you might not have projects, but basically we're just going to start off with scratch and just assume that everyone doesn't have no project. So we're just going to create a new project on the top left here, and just going to give your project a name. You can just name this rules right here. Database password, you can put it anything. We can just use generate a password, and you can just make sure you copy this. This will be used in n8n, and you're just going to create that new project right there. It's cool. So this is our Supabase setup, but now we need to actually set up the vector store database and table. And to do that, we're basically just going to use the SQL editor right here. Don't worry about having to code anything. Basically, we'll just use the n8n documentation and just paste the code that we need in right here. So you're going to come to the Supabase docs, and basically you're just going to copy this code right here. So you can just click copy in the top left. I'll have this link in the description down below, so you don't have to go searching for it. And it's going to come straight back to Supabase, and you're going to create a new SQL snippet right here, and just going to paste that code right in. You don't have to make any changes. You can change the table name, but I've seen in the past when you change the table name, it really does mess up with querying the knowledge base later down the line. So if you change the name and you're actually trying to search through the vector database, you won't be able to find it because n8n has it hard set to documents. So just leave it as documents as is. Run, syntax error. You can just paste that in again. Hopefully it will run. Yeah. Okay. So that's success. No rows returned. And if you come to the database, go to tables. Here is our new table. So we head straight back to our n8n. And we can just add an embeddings model. You can go to OpenAI. You can even use Cohere. I'm just going to use OpenAI. Text3 embedding small. And you just need to use an OpenAI connection to do that. Is your API key from your OpenAI. And to do that, just go to platform.openai.com. And I'll also add that link in the description down below, so you can just paste that in there. So once you've got your embeddings, you want to add the document splitter. You want to add the way it adds documents, and you want default data loader. And we want metadata as well. The metadata is just going to basically be the file name which we are referencing. That'll basically help with querying. Say if you have multiple documents in there and you want to find specific FIFA regulations and rules, you can have the file name used as the query in the final AI agent later down the line. So you can just have this as file underscore name. We'll add that later. So now we need to actually create the connection to our Supabase node here. So to do that, we can just click on this. And what we need to do is actually add a new credential, and we can just name this FIFA rules. FIFA rules. The host, I'll show you how to get that, and your server role secret, I'll show you how to get that. So head over to your Supabase. What you're going to do is go to project settings, go to API keys on the left here, the first one, and you want to server role secret. You're going to reveal that, copy it there, and you're going to come here and put it in there. And for the host, what you want to do is head back over to Supabase. You want to go to data API on the left here and grab this URL right here. Head back to n8n and paste it here. and you click save, and now you're all good to go. You're connected, and just let it load the table names. You want documents, embeddings, batch size 200 is good, and you don't need any query name. So that is basically it, and if we run it, it'll get added to the database. Before we just run this, we actually need to add the file name, and to do that we can just close this and loop over items. We're just probably going to use the file here. You can just say value is just this name right here, and we can also just remove the .pdf just for like searching and everything like that. To do that, we can just say replace all, and just put in .pdf here. That's what we're replacing, and we're replacing it with just basically nothing, which is just an empty quotation. And you can see we just got FIFA disciplinary code 2025, and that is it. And if we can just run over this, we can see how this whole thing works. I'm gonna unpin everything, and we're just gonna add everything to the vector database. So you can execute this workflow. It's gonna get the file, it's gonna download the file now, and we're gonna extract data from the file, and we're gonna just get the text here, and we're gonna default loader here, and we've got the whole file uploaded into the vector database. So that is basically already the first workflow done. Head over back to our table. You can kind of see what was inputted here. Go to tables. There's already 137 documents there, or chunks rather. View table editor. Yeah, so you can see FIFA disciplinary code 2025 edition. There's everything there. And if we go down here, protests, member associations, whatnot, everything there. Okay, cool. So if we go to n8n, that's the first one done. So we can just click save here and move on. So we're going to create a new workflow, and we are going to create an AI agent. We can probably use chat trigger, and we can just chat with it in n8n, but you can add it to anything like Teams, your website, basically any platform, your WhatsApp, any platform that you want. But just for this demo, we're going to use n8n, and you want AI, and you want AI agent. And now for the actual part which you came to for the video for, is we're going to add memory, right? And not memory, we're going to add a tool, and we're going to use Superbase vector store. And what we're going to do is include metadata and re-rank results. You see this button here? This is what's going to change the game for you. You're going to click re-rank results, and we're going to add the Cohere Reranker. So come to Cohere Reranker core, and you can just add your Cohere Reranker API child key. I'll show you how to get that because that's what this video is about. So head over to Cohere, and you can either sign up or sign in. You can just click sign in right here. And once you're in Cohere, what you're going to want to do is go to API keys right here, and you're going to get your production key, or you can even just use the child key. And you're just going to just press this eye icon here and just copy this key which you have. Head back over to your n8n workflow. Edit this. You don't want to edit it actually. You're going to add a new one, create new credential, and just going to paste the API key in there, and it's already connected and all ready to go. Use 3.5 because it's the newest one. And that's already it. And you're just going to go to your embeddings, OpenAI. Just make sure it's the same model which you did your embeddings in, and in the first workflow. So in the first workflow, we did it in small 3, embedding small 3 small. Make sure you're querying it in embeddings 3 small as well. Superbase vector store. So basically what we want to do is choose the table name. Just make sure it's actually the correct one, FIFA rules. And we're just going to have it load, documents, and limit. Because we have the Reranker, which was going to choose the top 3. We can increase the top K here, and that's basically the limit of chunks closest to your query in the vector database, which it will get. So you can use 30 here, but your query, the query which the AI agent is going to query the knowledge base, will be cross-encoding. You remember from the theory, it comes back with what's in the knowledge base. So we're going to put the limit of 30 there, and we can use, I can even put it more if you want. You can just, I'm going to put 40. Because it's going to choose the top 3, the Cohere Reranker. So yeah, basically just add a description of to tell the LLM what this tool does. Explain to the LLM what this tool does. A good specific description will allow LLMs to produce expected results more often. Use this tool to query the FIFA rules and regulations document. Cool, that's about it. I don't think we need to add anything there. And you just need to add a chat model and some memory. I'll show you how to do that. So you can add any model here. You can just use OpenAI. Same thing. The connections will be the same once you do the actual embeddings. You don't actually need a frequency penalty, and we can just use 4.1 many. We don't need anything special here. So for chat memory, just to make sure that it's a back and forth conversation like ChatGPT and all of that, we're going to use Postgres. and that's just going to connect to the super base, which we set up already. So we can use Postgres, and I'm going to walk you through setting that connection up and everything like that, and you can just increase the context window to like 15, for example. Cool. So yeah, let's set up this Postgres chat memory, and then we'll move into the AI agent prompt. I'll have that ready, and we can just paste that in there, and then that's basically about it. Okay, so setting up the Postgres connection is very simple. What you're going to basically do is just create a new credential right here, and you're going to click this connect button on Superbase at the top of your screen, and you're going to change the type to PSQL, and you're going to scroll down to session pooler right here and just click view parameters right there. And it's quite simple. So you're just going to grab the host, you're going to copy that, even let you copy, replace that there, leave the database as Postgres. The user, you want to change that to this right here. I'm going to grab that, just paste that in there. Password, this is going to be the password which you create in the beginning, and maximum number of connections, you can just leave that to 100. And the port, you're going to change that 5432. Actually, it's good, you can keep it the same. And I'm going to add the password, and you can just click save, and I'll come back to that. Just going to paste that password in there and click save. Yep, okay, that is everything set up. So now I'm just going to paste a prompt which I've already prepared here, and I'll kind of walk you through the prompt just in generally, and you can kind of go from there and start chatting with the AI agent and see how it works. So you can just come to the agent right here, and what we need to do is just add a system message. This will basically inform the AI agent how it should behave, and I've just pasted in the system message, and we can walk through it. So we're basically saying you're footy Barter, the world's cheekiest football rules expert with a banter level wit and PhD in FIFA regulation, arguing. Basically, you have one superpower, access to Superbase Vector tool, which you use to pull real answers straight from FIFA rulebook. Use it wisely to prove your point, and probably just remove this. I forgot ChatGPT to generate some of it. Point. Your behavior, example tones, tools. So you can use the Superbase Vector search tool to fetch any FIFA rules / regulation, including offside explanations, handball laws, VAR usage, red, yellow card, protocols, penalty kicks, etc. Style, and kind of whenever unsure, always just make sure that you say always fetch real data using a Superbase tool. Don't make stuff up, no matter how funny it might be. So basically just making sure that it's using the actual tool, and we are all good to go. So that is about it. Let us test this. So if we go to a document, we kind of grab that up here. We can see, use that as an example. Let's see. Duty to report, duty to collaborate. Let's see, I might grab something here to see if we can reference it. So basically here we just got the document open, and we're just going to ask the AI chatbot what are the rules and regulations around discrimination and racist abuse in football. So we can go over to the workflow, and we can ask that question: what are the rules and regulations around? We can just put this in. Cool. So we're going to use the tool. It's going to use the Postgres memory chat, and then it's going to use OpenAI. It's going to query the vector store. We've got a couple of items. We use the Reranker, and now it should be answering our question. So you can see here, we've got the whole bunch of embeddings, but then the Reranker picked the best ones. So if we come here, page content, here's response. We've got 1, 2, 3, the best 3. Alright, buckle up mate, because FIFA doesn't mess about with discrimination and racist abuse. Here's the skinny straight from the official playbook. If anyone, player, official, fan, whatever, offends the dignity or integrity of a country, person, or group using racist, discriminatory, or derogatory words or actions, they're in hot water. And if we come to basically the FIFA rules, any person who offends the dignity, integrity, or a country, person, or group of people through contemptuous, discriminatory, or derogatory words or actions on the account of race, skin color, ethnicity, basically straight from the document, and highly contextual to what we needed from this AI chatbot. FIFA has 3-step anti-discrimination procedure during matches. Step 1, referee tells the offenders to cut it out. Step 2, if keeps going, the match gets suspended temporarily. Step 3, if abuse persists, the match can get abandoned altogether. Host clubs and associations have to act swiftly to remove the culprits. And literally, straight from the document, re-ranked officially, and just perfectly answered. So that is about it. We can just label this workflow here: FIFA rules and regulations. FIFA rules and regulations. So that is a very simple chatbot. I will be leaving everything in the description down below, both to access to both workflows, and you can go around and play ahead with your own data and your own information here. And that is the power of Cohere Reranker. You get hyper relevant documents. Even when you return 30, you just pick the best 3 from that, or what is it, 40. And Also, once again, if you want to get access to these two n8n workflows, head over to the second link that's down in the description down below. You can download them, no strings attached, it's a Google Drive link. And if you're a business owner and you want to enable these RAG workflows in your own company and business, like to chat to your documents, all of that, hit the first link in the description down below to book your free AI audit. We walk through how something like this can be implemented in your business. So thanks for watching, and if you got value from this, please hit the subscribe button. And yeah, I've just got so much more videos coming for you. Bye.